So when the heart expands and contracts, these two layers rub against each other.
Yeah.
And it's really smooth and lubricated inside by a fluid. Okay? Yeah. So that way the heart doesn't withstand so much friction. Okay, so we're going to take it off like pajamas.
Nice.
Okay. So up in here. That's my cologne.
Except it doesn't.
Oh. Now when you take it off up here, you have to be careful that you don't damage blood vessels. Tastes like chicken. Now, in the lab, this would be the first thing you would do is to remove the pericardium.
The second one is the endo.
Which one are the last? The second one?
That endo, I have mayo.
Mayo is
Inside.
Mayo on the right side.
Yeah, like
So it's the
side.
endo.
Yeah,
Side of the endo.
No.
Yes. Mayo.
Or the endo, the last. So that's the mayo then.
So you would take your time, you wouldn't really rush. So you can see how smooth this is. This side is smooth, but this is really tough. Okay. Okay, so when you get your heart, the first thing you want to do is determine anterior from posterior. And there's a couple of giveaways. This is anterior. Okay? And the reason you can tell is, you see this line here, this groove? It runs from left to right on a diagonal. It's called the anterior interventricular sulcus. Sulcus is a groove, and you have blood vessels in here, coronary arteries and veins. Okay? On the back, it looks very different, and there's a posterior interventricular sulcus, but it's straight. So this is a landmark. It means on this side it's the left ventricle, on this side it's the right ventricle. Okay, so if you had an exam and had a pin in there and they said, what chamber is that?
Left ventricle.
Okay, right ventricle.
Right.
Now, the most anterior of the great vessels, see this one here? It's coming from this side, which you now know is the right ventricle. So what would that one be, you think? Coming from the right ventricle. Pulmonary.
Trunk.
Coming from the ventricles, blood goes into arteries. So it's the pulmonary trunk. The veins return it. Okay? Alright, so, and you see these areas here, this gray area here, and this one up here? Those are the atria. And a fresh heart would be reddish and more flexible. Okay? That's an atrium. Over here is another. So the first thing you do in the lab after that is you're gonna, I don't want to do it now, it takes too long, but you would clean up all this fat, and then you would see the different blood vessels and so on. Now here's a trick. Here's a blood vessel right here. See it? Alright, so if all this fat were cleaned away, I'm just going to do it quick and sloppy. Okay. Alright, you see the wall of this vessel, see how thick it is? And strong, elastic? Those would be arteries. So you know this is your aorta or a branch of the aorta. Now I'll show you this one. This is the superior vena cava. See how thin the veins are? Okay. All right. So we have a pulmonary trunk. We have the aorta behind it, like on the model, and it curves around. Okay. You'll be cleaning up all this fat so you could actually separate out. On the back, right around. Yeah. It takes too long. So instead of me going through all this and cleaning up, would take me almost a half hour. I'm just going to go right inside. So we're going in. So I usually cut it. I make a coronal section. Remember, this is the front, this is the back. So I'm going to cut it so I have an anterior and a posterior portion.
Surgery.
Open, heart,
You need a sharper knife.
I know. See, if you get a cow's heart or sheep, you just take a big knife and cut right through it. You'll see all the valves. It's a beautiful thing. How many of you have seen the movie Little Shop of Horrors?
Yeah.
Nobody?
I have.
You know, like, feed me.
Like it's cooked already. I didn't say that. Why are you looking at me?
Oh dear.
Still. The surgical knife is still. How long you had that?
Oh, since I was a kid. Okay. Now, remember, we said this was the posterior side, this was the anterior side, right? So, we said that this was the left ventricle, right? So when we open it up, okay. Okay. We have a problem here.
The measure's lost.
Looks delicious.
Oh,
Really?
okay.
Abnormality.
A little bit.
You messed it up.
Oh, I know what happened. See how this is compressed like this? It's supposed to be compressed like this. But that's okay. But right away I knew I made a mistake because look.
Oh, you cut it wrong?
What ventricle is this? These are your ventricles.
Left and right.
Which one has to pump the hardest? The left one?
The right.
The right only has to pump blood to the lungs. The left one has to pump in a much larger circuit. So which wall is larger? Right, so this is the left ventricle. That's the right one. Alright, so if this is the left ventricle, what valve would this be between the left atrium and the left ventricle?
Bicuspid.
Yes, what's its other name?
Mitral.
And what are these strings?
Coordinate tendon.
Coordinate tendon.
And you see this little nipple-like structure?
No.
Okay, it's right here. See here?
Yeah.
That's one papillary muscle. There's another one. It depends on... Okay. Okay. So
Papillary is below the strings, right?
papillary is a muscle that's attached to the ventricular wall. And it attaches to the valves by the chordae tendineae.
Are those things strong?
Yes. Here, pull it.
Oh
No,
no.
see it, okay. Can I touch it?
Oh.
Yeah, they're strong.
Wow, look.
What are they again?
What's that?
What are those called again?
Chordae, that's Latin for cord or rope.
Cord?
Tendineae, which means like a tendon. Okay. And these prevent, together the system prevents the valves from opening up into the
Oh, no,
atrium.
it's fine. I was just putting my
Alright, now, so what vessel would be coming up here? And if I put it through. Remember I told you before it was really thick?
Aorta.
Right.
aorta.
So that means, remember I told you about semilunar valves, that they're cup-like? So here, yes, well I have one right here. See how delicate it is? When blood strikes it from below during systole, it flattens out. Whatever little bit of blood is in there is injected and it flattens out. During diastole, some drops come in, and see how it bulges outward? And 3 of them bulge outward and meet in the middle, and blood can't go back. So this is the aortic semilunar valve. Who's got it? One of the pouches. Does everybody see that? Now, here's another pouch. Let me see if I could get... Well, if I can cut through here somewhere, I might be able to get the pulmonary semilunar valve, but... Let me cut even more. Alright, so if you remember, the AV valves separate the atria from the ventricles. So you see there's a chamber up here. This is left ventricle, so what chamber is this one up here?
Left atrium.
Left atrium. Okay. And they're going to tell you that the lining of the left atrium has, let me see if I can find the right one. See, because it's all compressed and distorted. Okay, so what would this structure be which separates the left and right?
Septum.
The septum or interventricular septum. So when you do yours, you're going to take your time, cutting off the fat. You'll be able to find individual blood vessels. You'll find the smaller. So this one actually is the inferior vena cava, because in the goat it's on 4 legs. So it's really called the posterior vena cava because it's coming from behind. And this one coming in, which would be equivalent to our superior vena cava, is the anterior vena cava. Okay. So if you want, anybody want to, clean this off, get the fat, try to identify the vessels, you can? No? Yeah? Okay. And also, if you take this home, you're guaranteed a seat on the subway. Okay, so, all right, so you can go back to your models.